Now that you guys have your devices, I want you guys to join the Google Classroom. I put the code up on the board. And I just want you to have a chance to kind of look around the Google Classroom and things like that. So finding the collecting evidence document was something that I want you guys to have a look at just to know where it is. Then I want you guys just to practice sending me an email and sending me a Hangout message just to make sure those things are all working. And then also check Google Calendar to make sure this course is showing up. And I'll show you where to locate the Google Meet links if we do have to use them. But take a moment to do that. I'm going to walk around, check who's here today, and make sure I got getting to know the names. All right, so with the devices, I just wanted you guys to kind of know where to find things. So I'll just pull up the Google Classroom page and just kind of go through some of the admin-y stuff. Close those things. And we'll unfreeze the screen. And we will duplicate it. You guys should hopefully all be on there. So I try to post things the night before in case you guys want to have any look at the note beforehand. But hopefully everything that you guys have used so far, you know where it is. So that's just all the stuff from the welcome that we did earlier. What else did I want to add? So I put in a lot of posts. Like I said, the first topic we're doing is structure and bonding. I've put the key resources there, so that's just going to link to my Google site. And when we go look at that Google site, it just takes you to the big kind of overview of the topic. So that's kind of the first thing that's there. And that's where you're also going to find things like the success criteria and the booklets and things like that. I've also put a digital copy of the success criteria, and I've made a copy for each student if you guys want to keep track of your learning online instead of on paper. I've also created a Google Doc if you guys want to keep your notes online instead, again, of on paper. So, and a copy has been made for each student, so it's very easy for you guys to access. And I'll talk about what kind of my expectations are with your notes. I'm very mindful that we are not really sure with the COVID environment how things are going to go. So I have created a Google Doc for unexpected event grade evidence. It's just for you guys to stick in like any answers to work, or if you're taking any photographs of your work, so that way we have a place for me to kind of very easily check to see your evidence, and I can derive grades from there if I need to. I'm also mindful that I will have paper stuff as well, so don't feel like you need to photograph everything. I can always flip through your SciPad, or if you've handed any work for me to look at and mark, I'll keep a record of what I've looked at and marked. So don't worry about making sure everything's there. It's just if you're doing anything online, or if you're doing anything remotely because you're not at school, there's a place for you to put evidence for me. Are we good with that so far? Cool. All right. So our first lesson is types of matter. And again, come on, load. It just links to my Google site. I like the Google site because what it means is that I can recycle it year to year and just kind of keep editing it. So I put the PowerPoint that I'm going to be using in today's lesson up there. Any written notes that I do by hand, I scan and put on there as well. The video recording of the lesson, I can't time travel, so that's going to go in after today's lesson. I'm recording it right now. And then what I like to do is give you guys some choices of what you do work-wise. I've given it at different levels, so you can level up. Some of the stuff we do have, some of the stuff we don't have, because it's from my previous school, such as the ESA guide, but that's fine. If you guys have access to any of those things, you can then use that as a reference point. So lots of resources there, and like I said, not expected to do all this work. It's just to give you guys some choices so you know how to study. All right, cool. I think that's all with that. I also want to make sure we check the calendar. So I have inputted our schedule into the Google Calendar, and that should be visible for you guys. And what I've done is I generated a Google Meet for the lesson as well. It's just in case we need to do anything remote, it's already there. Cool. All right, I think that's everything for that. So we can go back to the PowerPoint and we can start talking about what we When we start our lesson today, we're going to start it that way because I wanted you guys to get your devices out. So first thing I want you guys to do when it comes to taking your notes is writing down the date. That way you have a reference point. I'm happy if you want to do your notes digitally or if you want to do it on paper. It's up to you what you prefer. If you want to do it online, I've created that Google Doc for you so that it makes it easy to kind of put things on there. So it's your choice how you want to do it. If you don't want to do yours online, you're welcome to close your devices. We'll use them at the end of the lesson for Kahoot. But otherwise, if you don't want to do your notes online, you don't need to write them right now. Cool. So that's the first thing. Make sure you have the date written down. Today is the 10th. The other thing I want to make sure you guys have written down is your learning attention. So that way we know what to expect. What we're trying to cover today. So what we're trying to cover today is exploring the different types of matter and how we group them. So just real introductory stuff. The other thing I want you to write down in your notes is the answer to the mafia. This is our do now. Our do now today is just about kind of refreshing what you did last year and seeing what you remember from chemistry from last year. So that's normally how we will start most of our lessons. There'll be this slide up on the board, and you can just hop right into it, get your notes open, and get going. Things that are highlighted in yellow, it's not common for you guys, but it is for everybody classes. It's just stuff you want to make sure you write down. Most of your notes, though, I've printed for you in the booklet. So I'll give that out to you guys in a moment, but I'll let you guys get started. Recording. Yes, it is. Okay. Cool. So let's go with the mafia. So we were thinking about what we learned last year, level 1 science, in particular with chemistry, and they want to share some things they remember. I wasn't a teacher here, so like I don't know what you guys learned.
Balancing equations.
Yep, balancing equations. Chemical reactions, good. We're going to do a lot of those two things together. In particular, we're going to be focusing a lot on neutralization reactions and also precipitation reactions this year. So you will be reusing the stuff from last year. Anything else that people kind of remember from last year? Genetics, yes, but this is the question for chemistry. Genetics is the right answer for the next period, though. Yes. Exchange reactions, good. So that's another one of those types of chemical reactions that we're talking about. Is that a hand or a stretch? Displacement reactions, good. I'm sorry, what did we do? I don't think so. But yeah, it's good that you guys remember and recognize some things. What I want to focus on today is going to be thinking about the different types of matter and how we group them. If you guys remember the other day, I was talking about the 3 categories of questions, and the first category is types of solids. So that's what we're focusing on and getting kind of an introductory to it. So let's look at today's lesson plan. We actually covered some of this in the last lesson because we had a little extra time. You guys have done your device setup and you've kind of figured out how you want to do your notes. So what I'm going to move on to next is talking about the different types of matter and give you guys some notes on that. We will talk about classification and practicing that sort of thing. We'll talk about the characteristics of matter, and then we'll finish up the lesson with a conclusion. So you will need your devices later. Cool. All right. So we've seen this video, and we've also talked about what level 2 chemistry is about. And I think I've already talked about what 2.4 is about as well, haven't I? Yeah? Just kind of recap. Cool. Let me pass out some resources for you guys. The first resource I have for you is a piece of paper, and that is the checklist of the success criteria and basically all the content. There is an online copy of this. You're welcome to use that as well. But I figured I might as well figure it out if you guys want a hard copy. Okay. Yeah, you're welcome. double-sided, so I don't know how you're gonna. Yeah, not hard work, because I know you guys will definitely wanted that, because that's how you get home.
Can I give you my laptop? Thank you.
What do you need? I'm gonna need it at the end of the day.
Oh. No, no.
Okay. All right. Cool. For the success criteria today, we're looking at can we distinguish intermolecular and intramolecular forces. So starting to look at some of the vocabulary for chemistry. Cool. The other thing that I will pass out are my booklets of notes. Again, this is just what I show on the PowerPoint. So it is online, so it's an online copy. But if not, here's a hard copy. Like I said, it's really good to get used to the notes this way. This is what we're going to do in university. We're going to give you stuff like this. Then you just kind of jot down as you're listening. There you go. Okay. Cool. And let me get my little clicker as well. All right, so first we're going to talk about is how to classify different types of matter. And this should hopefully be a refresher from like the junior school. So the first thing to think about is what is an element? And an element is just talking about a pure substance, and it's only made up of one type of atom. Don't worry about popping down everything in the PowerPoint because, like I said, it's in my notes here. So if you go, you look at that first page, it's all up here. So you don't need to worry about like madly writing down everything that I have on that screen. Okay? That's the reason why I gave you the book. The next thing that we're thinking about is a compound. So when we think about compounds, again, it's a pure substance. When I say pure substance, I'm saying it's just made up of that one thing. The difference with the compound is now we have two or more different elements. So I'm grabbing a couple things off the periodic table now. And these guys are chemically joined together. So there's a chemical bond that holds together these two types of atoms. If, for example, I have two atoms and they are exactly the same, I still have an element. A good example of that would be, for example, oxygen gas. So if I have O2, I just have two oxygen atoms attached to each other. That is still an element because it's just the one type. If, however, I put a C and I have CO2, I now have two different types of elements. I have carbon and oxygen, and that is now a compound. The next thing that we're going to talk about is mixture, and that's when the substances, again, are different. In this case, when they are mixed together, they are not chemically bonded together. So since they're not chemically bonded together, I can then separate them. So the difference between these two here, a mixture I will be able to separate. A compound, the only way I separate those atoms is by doing a chemical reaction and pulling them apart. So do keep that in mind when we're thinking about the vocabulary. Molecule is another word you might hear us refer to, and in fact, I'll refer to it in this types of solids section. And that's just, it's like a compound, it's just a smaller version. Most of what you're dealing with in this level is going to be molecules. They are chemically bonded together, but they could be elements like oxygen, or they could be compounds like water. Are we good so far? Okay. Let's practice our classification. So I have a list on the board, and I want you to discuss in your group which ones are compounds, which ones are mixtures, and which ones are elements. So, take a moment. I'll take a break from you chit-chatting. Better figure it out. Great. I love playing games. I think it's real good fun. Okay. So, the game that I want to play is the last person standing. We're going to go through this list, and you're going to answer what you think it is. So, on your head, means you think that answer is an element. On your shoulders, you think it's a compound. And on your hips, you think it's a mixture. Yeah? We're going to all stand up. And the moment you get one wrong, you sit down. The last person standing gets to fill the shoulders, hips. Shoulders, head is element, hips is mixture. So it's just the same order. I'll write on the board. So element is your head, shoulders, and then hips. All right. So first thing I have listed is beer. So is that an element, compound, or mixture?
What's mixture again?
Yeah. Element, compound, mixture. All right. If your hands are on your hips, you can stay standing. You are right. That is a mixture. All right. Argon. You're right. It is an element. All right. Common salt is talking about sodium chloride. Sodium chloride. I'll write that on. That helps. That is a compound. All right. Mercury. Mercury. All right. Element. So if your hands are on your head, you can stay standing. I'm going to knock some of you guys out. All right. Right, that's an element. Sugar.
Wait, what's that?
Sugar. You don't have to make yourself a lolly today. Okay. Okay, iron sulfate. Decide. Put your hands over. It is a compound. You guys are looking at each other. All right. Potassium. That's an element. All right, fruit juice. Mixture. All right, blood. A gradient of blood. You guys are moving each other. I'm going to tell you that this one is a mixture. Don't worry, just stay standing. I think everyone gets wrong, right? All right, rubber. I'm actually not sure about rubber. I think it depends on what rubber you get, because in some cases I think it could probably be a compound, but just pure, like whatever that chemical formula is. But I can also see it being a mixture, because they might mix other things into the rubber to make it whatever property they want. So I'll give it to you if you have compound or mixture. All right, wood.
The mixture?
I would probably say it's a mixture. All right, do we still have people standing? Yeah. It's a hard one. I would say it's probably a mixture because a compound I need a chemical formula, and with wood there's other things in there. Oh, there's another one. Right, everyone that was still standing, the last one coming up looking. I knocked everyone out. All right, butane gas, element, compound, or mixture. That one is a compound. Sulfur dioxide. Compound. Water. Compound. That was all compound. All right, moon rock. I would say this one's a mixture. You were stretching. Sand. Mixture. Sit down if you got compound. All right, hydrogen. Element. All right, melt. Mixture.
Oh,
All right, sodium bicarbonate. That's a compound. And then last one, bronze. Element, compound, or mixture. It's not an element.
it's not?
No, So it's a mixture of two metals. So actually, mixture is probably a more accurate description of it, but I'll still give it to people with compound because there are metallic bonds when it comes to the bronze, and so that kind of falls in the category of compound, so I'll give it to you for that too. All right, last people standing, you guys get yourself a lolly today. Yay. Congratulations. Good job. Well done, we're guessing correctly.
Yeah, exactly. Yeah.
And we'll go back to our slides.
I want to stick that.
Go for it. Those are coloring like postcards. Yeah. All right. I'll keep going with the notes. You guys figure out your prize. Let's talk about changes. So, there's two types of changes that we refer to in chemistry. The first one is physical change. I don't really like the definition of easily reversed, but that seems to be the common kind of terminology we use. It's like, for example, if I rip a piece of paper, I would describe that as a physical change, the change of paper. But you can't easily reverse that. So what we're thinking about in this case is like, have we done something like changing states is a good example, or if we're dissolving something like salt, we can reverse it. Chemical changes are more difficult to reverse. In some cases, they might be impossible to reverse, and that's because we're resulting in a chemical reaction. We need to actually break bonds that are between atoms and then reconstitute them together. This is going to be important to think about for this topic. We talk about physical changes quite a bit, and we look at it in the context of melting and boiling. Cool. Whereas chemical changes, we'll talk about another topic. I don't want to do that too much in this one. Actually, we do a little bit with the empathy. All right. So let's think about some of these examples. I've put 4 on the board. We have boiling water, frying chips, lighting a match, and sugar dissolving in water. So I want you to again discuss in your group which one of these are chemical changes and which ones are physical changes.
Wait.
I see some really good debates, which makes me happy. So, boiling water is going to be a physical change. Physical change, you can reverse that. We can condense the water back down into a liquid. We can also freeze the water and still H2O. So we have no chemical change there. All right, chips frying. So if I was cooking some chips, would that be chemical or physical? That's a chemical change. It's not easy to change that back. And on top of that, you're going to be changing what you have at the molecular level with the new compounds with the cooking process. Lighting a match. Chemical one as well. And then dissolving sugar into water. There's a lot of going back and forth. That one is a physical change. One can reverse that. Basically, you evaporate the water away and you'll let the sugar. Does that make sense? Yeah. If you want to try that at home, I suggest doing it with salt water because the problem is sugar cooks at the heating, like when you heat it on an element. But if you want to do it with salt won't cook. What you can notice is you have a can of water, put a little bit of salt, or you put a decent amount of salt maybe, evaporate the water away, and you'll notice there's these crystals of salt left over in your can. And so that's the same sort of process thinking about dissolving. And we'll talk about dissolving as one of our specific types of properties later in this topic. All right, let's move on to the next thing and think about types of bonds. So we had a brief kind of look at this. Once I get my clicker to work, there we go. So there are 2 types of bonds that we need to be, more than 2 types of bonds, but 2 key ones I want us to learn about today. And this is really important for us to understand why is there certain properties to these different types of matter. So we're going to be referring to both types of kind of bonds that we're thinking about. The first thing that we are thinking about is in cell molecular, and I highlight the T R A because these words look very similar. And so I'm highlighting the section that's kind of helping me identify which one's which. So intramolecular bonds are the bonds between the atoms. So if I was looking at this atom over here, or sorry, these water molecules, I'm thinking about the bond between the oxygen and the hydrogen for those intramolecular bonds. So basically, when I'm looking at this guy here, I have a little model. This is a molecule. When I'm thinking about intramolecular bonds, I'm thinking about the bonds that are holding these two purple bits together. Oh, I wasn't supposed to be able to pull up. I'm so strong. But if you were to, it's obviously going to be a lot of force to do that. You have to do a chemical reaction. Broke my toy. Molecular bonds. You see how I have the TER instead? We are talking about the bonds between molecules. So this is really specific for molecules. And we'll do a whole lesson on molecules. But what we're thinking about in this case, I have a water molecule and it's attracted to another water molecule. So the bond here is my intermolecular bond. The way I like to remember it is I think international. We're going from one molecule country to another molecule country. Okay? These are really important to keep in mind. We will go into more detail of specific examples and categories of each one of these types of bonds. But we need to know these bonds because we're going to be explaining the properties of the solid based off which bonds are there. So basically, we're thinking about how strong are those bonds. We're also thinking about how much energy it will take to break those bonds. So when we are explaining any of the properties, we are thinking about at the atomic level. So if I didn't break my little model, I have these two purple molecules, and the bond that's attracting these two molecules are the intermolecular. Yes. All right. So like I said, understanding the difference can be really important when we're trying to justify properties. The next thing we need to think about. There are 4 different types of solids that I will be teaching you about. The first one we're thinking about is metallic. For example, like gold and silver. The second one we have is ionic, so sodium chloride, which we know previously as a compound. With the metallic, you're going to be dealing with things that are elements. Then we're going to talk about covalent networks. Have you seen the word covalent before? Like covalent bonds? Is that new to you guys? You're sharing electrons. That's pretty much. Don't worry if it doesn't, because I will teach it. I'm just curious to see if you guys know it. So, networks. We are thinking about multiple different things. This is a huge range of category. It could be stuff like diamond. It could be stuff like graphite, which is what you have in your pencils. It can also be stuff like plastics, like the little model I just wrote. And the last one we're going to be thinking about is covalent molecular. Be really careful with this one. They're both covalent because they both have covalent bonds, but they have dramatically different properties. Yeah. Yeah. Same difference. You can hear it referred to as that. So there's lots of different ways they refer to it, but the main thing you're thinking about is molecular. Okay? In this case, we're thinking about frozen water. We're also thinking about dry ice. Do you guys want dry ice? Ice. It's a smoking thing. It's basically solid carbon dioxide. Yeah? That is really cool. Really cool. So yeah. The reason why I'm specifying these as solids is because we're thinking about types of solids. So keep that in mind. When we talk about water, we're talking about ice cubes. When we talk about dry ice, we're talking about carbon dioxide that's frozen solid. Okay? And that's really important to keep in mind when we're talking about these important properties. Cool. So my next thing to note for you guys is that classifications are really, really important for this question. So this question you guys see on the exam is basically going to give you guys some of these solids, like I listed. They'll give you a specific example, and they're going to ask you to classify and explain its properties. What would also happen, I haven't really seen it change, is they start the question with a box to fill in, and they ask you just to classify. This is really important to get right because if you misclassify the type of solid and you start justifying it based on the misclassification, you won't get any points for that answer. Does that make sense? So for example, if I misclassify sodium as an ionic compound and then I do all the justification as an ionic compound and say its properties that way, there's no point. So it's really key that you take your time and get this table correct. The other nice thing about this table is that it helps set up your answer. So the two things you need to really be thinking about when you're justifying your solid is the type of particle that makes up that solid and the force that holds those particles together. So I'll go through this as an example in a moment. I think we have something else to do first. Yes, it's talking about how we classify. So we need to think about the periodic table whenever we are classifying. So you'll be given a periodic table on the assessment. Make sure you have it out in front of you. This is in your notes. But whenever we're doing some work, we'll make sure to have a periodic table in front. The main thing you want to keep in mind in that periodic table is where that division line is. So there's a line roughly around here with aluminum, and it's to help you classify the metals and the non-metals. Most things, elementally, are metals. All right? Now, the reason I'm pointing that out to you guys is that that's going to be a key factor when you start classifying. So first thing, if you're trying to classify and you see that you are just given an element and that element is a metal, then you have a metal solid. And then you start accessing all your knowledge about metal. So basically, they pick something off the periodic table like sodium, that's your metal. The second thing is the ionic solids. So we know that's another type of compound that we're thinking about. To figure out which one is the ionic solid, we need to see, first off, do I have a compound? You should have two different elements at least. The next thing you ask yourself is where are those elements located? Do I have one that's a metal and one that's a non-metal? If I have two non-metals, then we don't have an ionic compound. And you shouldn't be given two metals. If you're given two metals, then you are dealing with metals. All right. The next one is a little bit trickier, and that's the covalent. So there's going to be lots of overlap with our covalent because the covalent networks and the covalent molecular, you're looking for the same thing. So we are looking for non-metals with the covalent networks. Sometimes it's just the element, so it could be just one thing like carbon. Other times it could be a mixture of metals. It's either covalent network. My suggestion to you is you or boiling point. So usually mention one of those two things in the other parts of the question. So that's what the NP and BP stand for. If I'm for the covalent network, they're most likely giving you something that's going to have a high melting, high boiling point. So what you're looking for in that case is that it takes a lot of heat to melt that substance, or it's like, for example, usually they say it's like the really high temperature or it's a solid at room temperature, that sort of thing that you're looking at. For the covalent molecular, they are on the opposite end of the spectrum. They have a really low melting point and a really low boiling point. The two things to kind of look for when you're, again, reading the question. The first thing is it'll state that its melting point and boiling point is really low, like in the negative. The other thing you will see it state is that it's a liquid or gas at room temperature. Those are your two hints you're looking for. If it's a liquid or gas at room temperature, it must have a really low boiling point and a really low melting point. Otherwise, it would be a solid. Does that make sense to people? The example that I could use is water. So water, for example, is a covalent molecular. Water at room temperature is a liquid. So that is a low melting boiling point. You know, water melts at 0 degrees and it boils at 100. So that is a good example. Another example of that would be carbon dioxide. The carbon dioxide right now in the air is a gas. So it's going to be quite low to get it to a liquid and quite low to get it to a solid. Are you okay with that so far? Questions? All right. Let me show you guys an example of classifications. So I'll get my document camera out and I will go through how I would go model figuring out the answer to that. Yeah, I think it makes me twice today. Let me get my document camera. All right, so what I've taken here is an example from one of the NCAA questions. This one, I can't remember what year I've taken it from. So, like I said, the first thing you need to be doing is classifying those types of solids to make sure you have the right thing that you're working with. So, the first one here I see is sodium. I already know, thinking about what we did earlier today, that this is an element. And the next thing I need to then, actually, should we go through and just classify things as element, compound? So that way it helps us kind of get started. So sodium, just by itself, element. Sodium iodide, I see that I have two different elements here. So this is my compound. And then last one here, I have iodine, and I see I2. So that one is my element. Are we good so far with that? All right. So unfortunately, that's not what the question wants you to do. You have to actually classify it as a type of solid. And we know there's 4 different types. There's the metallic, there's the ionic, and there's covalent network and covalent molecular. So we're going to be looking at the periodic table for that information. First thing to look for is sodium. Now, this is the exact same periodic table you guys are going to get on the assessment. So do be mindful they don't give you the names of the elements. So you do need to recognize them. Sodium, I see, is on my left-hand side. So what would that be? Just a metallic metal. They're not going to be too fussy if you write metallic or if you write metal. Are we good so far? All right. Next one is sodium iodide. So I see sodium again, and then I'm looking for iodine, which is over here. Let me move my document camera a little bit up so you can see the whole thing. Sodium and iodide. So we know it's a compound. We see a metal and a non-metal. So what would I classify that as? Nah. If I have a metal and a non-metal, it is ionic. You see what I'm saying? Classifying is going to be the first key to this question. You misclassify, you write up a long answer that's beautiful, but if it's like the wrong classification, you don't get any points, unfortunately. So take your time and get this right. All right, last one I have is iodine, which I see was right here. So that is a non-metal. I have 2 of it. So we know it's either going to be covalent network or covalent molecular. If I'm not sure which one it is, I go through and I read the rest of the question and I see what it tells me. So we'll start with covalent. Now with this covalent, let's say I read the rest of the question and it says that it's a liquid at room temperature. So what would that suggest I have? A molecule. So I write covalent molecular. Are we good so far? All right. There's also the types of particles and the attractive forces. Do you guys want me to kind of give you those now? All right. So, type of particle that makes up that solid. In the case of the metal, you're going to write down atoms. And we'll see that when we do our lesson on metal. The bond that holds the atoms together is very simple. It's a metallic bond. Cool. All right, next one. Again, a lot of these are very logical. Ionic compounds are made up of ions. Do you guys remember what ions are? All right, in case you don't, an atom gains or loses an electron to fill its valence shell to be more stable. That's now a charged particle. So it's either a cation, which is positive, or an anion, which is negative. So those are obviously made up of ions. So ionic compound, ions, and then what type of bond? Do Ionic bond, which you guys did last year. All right, covalent molecular. Again, there's a hint in the name of what we're dealing with. In this case, we are dealing with molecules. All right, do you guys remember the force that was in between those two molecules? International. So intermolecular bonds, or you can say forces. I'm not fussed. I like the word forces because that's more specific. Bond we refer to more so as chemical bond. All right, what's missing from our list? Covalent network. So that is not on our list, but let me talk about it so that way you guys have it added. Covalent network. If you have anything classified as a covalent network, you'd expect it to have a really high melting and boiling point. The type of particle that holds it together is also atoms. So basically, you can memorize this kind of table so you know what particles you're referring to. The types of bonds in this case, again, the name hints to what you're dealing with. You are dealing with covalent bonds. And I do have this later in our booklet, so that way you guys can summarize it at the end. But I just figured I might as well start you guys off thinking about it. Questions so far? No? All right. Can I move it? Yeah. Oh, I still see some pens moving. I will scan everything that I write, so you know on that Google site how I had scanned notes. This will be some of the stuff that would be scanned. All right, we good? Okay. So, what I have left on my lesson, we have a Kahoot to play. How do we have? We have about a half hour. So I'm not used to like try to make sure you know which is which. I will put up the no brain too small. And we want level 2 chemistry. So the nice thing about no brain too small is like just how many resources are here. We're going to structure and bonding. And we are going to go. So I love the collated questions. You remember how I said there's categories of questions? The collated questions are like helping you learn the categories. So we are going to be looking for the, let's see, bonding and property. I'm guessing that's the one I want. There we go. All right. I'll copy this onto the Google Classroom page as well. So we'll have little chances to study and practice. If you notice, there's obviously these tables that we've talked about, and I want you to go through, classify the type of solid, and then refresh particle, attractive forces. Sound good? We'll do a couple of minutes of that, and then we'll play our Kahoot. See what you guys do. All these questions here. Yeah, do it in your books. Skip the questions that obviously want you to write up the answers. Just go straight to the tables. Okay? I'll copy this onto the Google Classroom page. Level 2. I'll link it on Google Classroom. Practice completing the classification tables only. There you go. We good? Right, I'll leave that up on the board. I can zoom out a little bit so you guys can see some choices. Oh, you can actually see the whole thing. I'll do it like that. All right. I'll leave that up on the board. Yeah. Okay. I just scrolled down the answers so that way I can kind of talk you through some things to point out. Sulfur is quite a tricky one. If you guys Googled it, its melting point is like 400 degrees Celsius. This one, in the grand scheme of things, and you'll see when we start comparing and contrasting, 400 is not terribly high enough. Sorry, 400 degrees Celsius is not high enough for me to state covalent network. When we're thinking covalent network, we're thinking like over 1,000. So if you look up silicon dioxide, it's I think 1,400. So that's the realm we're looking for covalent networks. So this one is molecular. The other hint that I have for you guys, I'll scroll back up so we can see the answer to that first question. There it is. So, nope, that's not the one. That's the one we did in class. One more. There we go. All right. So this one here, we see silicon dioxide, we see chlorine, and we see potassium chloride. Potassium chloride is obviously very ionic because we have a metal and non-metal. These two here are both covalent, right? So the hint for you guys is to read the rest of the question and figure out which one has the high melting point and which one has the low melting point. They may not necessarily tell you guys both, so they might tell you one, and by process of elimination, you figure out the other one. Does that make sense? When it comes to these tables, what they're likely to do is give you one of each, so there shouldn't be any doubling. Does that make sense? So both of these are covalent. It's unlikely that they're both covalent networks or they're both molecular. One is going to probably be molecular, and one's going to be covalent network. Think about it logically. They want you to write up an answer to compare and contrast, so they should give you two different things to compare and contrast. So read the rest of the question, and I can give you some hints on which one you are dealing with. Does that make sense? All right, shall we play some clues? Yeah. If you have the success criteria, so our lesson today was to define the different types of solids. Wrong, what are those? Sorry. Exploring the different types of matter and group them, so more or less the same thing. Success criteria, you guys should be able to do number 8 and distinguish inter and intra molecular forces. You should also, it's not on the checklist, but it is something to keep in mind. You should be able to talk about the more types of colors. Cool. Let's see if we can learn if you didn't hear anything or hear it a little bit, feel free to put it in the comments.